This is the first video in a series that will be following the progress of our compost pile. It's October 2016 on the Plateau Montreal in Montreal, Canada. My golden doodle Newton and I have been preparing an active compost pile since about 10 days ago. This is our passive composter. I built it in June, and it relied on the larger detritivores like sow bugs, worms, and centipedes and snails to break down organic matter. That makes it a passive or cold composter. I transferred the compost in it to the active compost pile that I built to take over the job of composting from now until the spring. This is an active compost pile, so it has to be at least a meter in diameter. In fact, this one is 1.5 meters in diameter. Well, in fact, it'll get cold here in Montreal, and I want this to keep composting all winter long. So I placed the supports that I put together out of 2x4s to make a hexagon with a long diameter of 1.5 meters. It'll be about the same height, and that should keep the core well enough isolated from the cold around the sides so that I can keep composting all winter long. I'll have to clear the snow around the sides of the pile so that the air can circulate into the center. Passive composters are not really practical for a cold climate like Montreal. They can't generate enough heat to overcome the winter temperatures. So we're going to be following the progress of this large pile throughout the winter. The composting ingredients are carbon, nitrogen, oxygen, water, and microorganisms. So let's take a look at them. The main source of the carbon is the fallen leaves and little twigs and mulch. Some of the leaves that I've been raking are brightly colored and still have green on them, so they contain much more nitrogen than dried brown leaves would contain. And the neighbors are leaving me also their leaves and garden cuttings from the yard, so I'll be adding them throughout the winter. The goal is to wind up with a compost ingredients or compost pile that is about 30% carbon or 30 parts carbon, I mean, to 1 part nitrogen. So things that are higher in nitrogen are fruits and vegetables, the peels and coffee grounds left over from the kitchen are high in nitrogen. So I keep a box here. I put up a box that neighbors can drop off their vegetables and fruit discarded from the kitchen. So since this is an active compost pile, it should be operating all winter long, and the neighbors can keep bringing their organic waste here. And I'll do what I've been doing and just bury it under the leaves at the point where I can feel the heat. And the microbes are going to feed on that. So the compost pile also needs air, or at least oxygen. It needs the oxygen from air. And to try to encourage that, I rolled up a steel mesh into a column to make a chimney, and I put that into the center. It's just supported by the compost on all the sides. After 4 days, the compost in the center was already hot, too hot to even put your hand into the center. Well, it was uncomfortable to put your hand in the center. And when you put your hand over the top of the steel mesh, you can feel the heat rising. So in the dead of winter, especially with the temperatures well below zero outside, the effect should even be more apparent, more exaggerated. But we'll see about that. So the heat rising from the center of the pile creates a vacuum in the center that draws air in from the sides into the center. So that air that's being drawn in from the sides will have to pass over all of the compost material, supplying it with oxygen. The mesh has holes that are too small, too narrow they won't let compost pass through them to clog up the chimney. I've chosen not to water with the city water out of the hose, which is treated with chlorine precisely to kill bacteria in the water, but I want to nurture bacteria. So instead I'll be using rainwater. I check the forecast, see when it's going to rain, and add leaves just before it does. So it's watered naturally after each layer. If it rains too much, as it's doing these days, I cover it with a tarp so that it doesn't become saturated, soaking wet with rain, with water. Now, but it seems that the compost pile is able to absorb a pretty heavy rainfall all the same. When it starts snowing, it'll be easier for me to keep the level of water just where I want it in the compost. Um, once it's at the right level of moisture, I can just clear the snow from the top, and of course clear the snow from all around the sides so that oxygen can enter. And I'm assuming that the heat that's emanating from the pile should be sufficient to melt the snow on the top on a continual basis. But we'll see about that. Now, for the microorganisms, uh, Newton and I went up to the mountain where there's a lot of forest, and we took 4 samples of soil from underneath healthy parts of the forest and brought them back and sprinkled them into the compost. And so that was that's how I intended. I've been I tried to introduce a wide variety of bacteria and fungi from a forest that's been that's been untouched for decades at least. For the larger invertebrates, they're called detritivores. Well, all of this is detritivores, things that break down organic matter. But the worms, sow bugs, snails, centipedes, and others, when I transferred the compost from the passive compost file, there was a lot of that kind of life in it. So that they're now finding their place in the active compost file. Now, just a word on what it is we're actually trying to do here. Think of an old growth forest. An old growth forest, no one ever suggests that you should go into an old growth forest and add fertilizers and herbicides and insecticides to improve the on nature and to help the trees grow, etc. Because for a very good reason that everyone knows really that nature works. That bacteria have been around for 3.5 billion years, and for hundreds of millions of years, bacteria have been working symbiotically with plants, with vegetation. And so what we're trying to do here is to imitate nature in a way that allows us to uh, reintroduce into our soil what nature has learned to do over billions of years. Um, and, and it's been composting. The reason that people don't go into old growth forests to add fertilizers is that there's no need. Compost bacteria and uh, all of the detritivores keep the system going. Plants know how to use the the nutrients that they make available. Plants know how to use those bacteria and those fungi to ensure that they have the the nutrients that they need to grow and to stay healthy. So what we're doing here we'll just finish off with what composting is. Composting is the aerobic decomposition of organic material. And the bacteria use carbon, nitrogen, oxygen, and water to reproduce exponentially through division. They divide. They relied on oxygen from the air that has been diffused into a film of water that envelops organic matter like leaves and vegetable litter. And a byproduct of that bacterial reproduction is heat that you can see here as I'm turning it over. Heat is rising even after a few days. In fact, the temperature goes up to 60 degrees Celsius in this pile. So in reproducing, the bacteria break down organic matter that contains around 30 parts carbon to 1 part nitrogen. And in turn, the protozoa, nematodes, mites feed on the bacteria. And then the larger invertebrates like the sow bugs and the worms, snails, and the beetles feed on them. And everything that eats poops. And the plants rely on that poop uh, to grow, to extract nutrients, and the whole system, the soil food web, flourishes. It's that biology that we're trying to reintroduce into this soil on our little property. However, this is part of something that needs to be done on a global and is being done by people uh, who are informed and committed on a global basis. So that's it for now, and take a look. We'll take a look at the progress over the coming months.